I want to welcome you not only to the Johnson Space Center, but most certainly to the White Flight Control Room. This room that you see in front of you is one of 5 mission control rooms located in this building. It first opened in 1995 when they added this section onto the original building. Now, it opened in 95 and flew its first mission in that year that was called STS-70. STS stands for Space Transportation System, and that's the formal name for the space shuttle. It went on to fly a total of 66 shuttle missions, including the very last one that was called STS-135 in 2011. Now, if you look along the top of that left-hand wall, you'll see 66 mission plaques there. Each one of those represents one of those flights. Now, this room serves 2 current functions. First of all, this is the prime backup room for the ISS Mission Control Room. By the way, in 2013, they tore this room apart and rebuilt it to the way you see it now. This is called an MCC-21 configuration, which stands for Mission Control Center for the 21st Century. In 2016, they did the same thing with another room on the opposite side of that building. That's where the ISS, or International Space Station Mission Control Room, is located. And you can see it if you look into these TV screens in the upper corners. Now, those people that are in there are literally flying and controlling the space station. The astronauts on board the station are really there to serve as researchers and scientists on an orbiting scientific laboratory, and they stay exceptionally busy. Each one of them will be up there for about 6 months, and during their stay, they're going to work on at least 200 different experiments. So they certainly don't have time to be flying and controlling the space station. Now, this room is being used currently as a backup for that mission control room in case something malfunctions in there. And then also it serves as a training and qualifying room for future flight controllers. And this is a critical job. To be a flight controller, that's one of the most technically challenging and difficult jobs you can find anywhere. Plus, there's an additional burden. You don't make mistakes in there. That's absolutely unacceptable because that space station is not only worth over $100 billion, the lives of the astronauts are always in their hands. It's 250 miles up, and being out in space, it's in the most violent environment known to man. There are an incredible number of hazards that they have to carefully watch for at all times. Now, if you want to be a flight controller, if you have a bachelor's degree or better in a STEM subject, which is science, technology, engineering, mathematics, apply for the program. If you're accepted, you'll train for 3 to 3.5 years. During that time, you'll go through hundreds of hours of classroom training. You'll also be a member of a support team. Each one of the positions in mission control has a staff of people that assist them in their job. And then lastly, you'll be in here for 6 months to a year flying simulations. Now, those simulations are identical to the real thing. In fact, they're so good that experienced flight controllers will tell you they can't tell the difference between a simulation and the real thing. But there actually is a way we can tell. Now, when they're flying simulations, they're after 3 things. First of all, they're certainly training them and teaching them hands-on how to do their job. But the other 2 things are directly related to how good or bad a day they're having. In the real mission control room, they very rarely have a bad day. In fact, look at the upper right-hand corner of that big screen on the wall. You see the blank area? That's where they show warnings or cautions of any kind of problems. If it's a caution, it'll be in yellow, and that just indicates it's a problem, but not really pressing. Take care of it when you get a chance. But if it's in red, that's an emergency. It's called a warning, and they require immediate attention. Now, every day in the real mission control room pretty much looks like that. But if you're flying simulations, every day is a terrible day. That'll be nothing but red and yellow lines. Now, of course, they're teaching them how to fly their console, but they're also hitting them with every problem that they can conceive of on that space station so that you quickly learn how to identify it and also the right solution. Now, to that point, they are also forcing them to make mistakes. They want them to. This is a very positive means of training because when you're forced into making mistakes, then you learn the right way and you really learn better how to identify and solve it in the real space station. Now, the last thing that they're doing is they're pressuring you. By loading them up like that, even experienced flight controllers tell you that they feel a sense of emergency and anxiety. And by doing that, if you're in there and you start getting upset and you get agitated and you start rushing things, you're not a good fit for mission control. Because what they're after are the kind of people that even under the most dire emergencies just calmly sit and quickly solve the problems. You have to really have nerves of steel in there. Now, let's take a look at that big board. Wow, we got some good views. If you look over on the left-hand end, that's what we call the 6-pack. Oh, the 3 views across the screens across the top and the one in the bottom right-hand corner are live outside shots of video views from the space station. And it's a really nice day. Obviously, they're on what we call the day pass, which they're on the day side of the Earth. And if you'll look on that tracking chart, that big map in the center, we can pretty easily find it. First of all, you see those curved white lines? That's the path that the space station flies over as it orbits the Earth. Now, it look curved, but in reality, they're not curved. It's just that when you fly around the globe, you're flying in a circular orbit that's tilted. When you flatten that out on a map, it looks like a curve. Now, if you find the space station, it's going to be real easy. Look over close to the left-hand side. You see just to the left of South America, that squashed white circle. It has what looks like a butterfly with rectangular wings in it. That's where the space station currently is. And it's flying right now from northwest to southeast. And before you leave here, it will have flown over the southern tip of South America. That's because it's moving at 17,500 miles per hour. That's 5 miles a second, or about 8 kilometers per second. And it has to fly that fast. If it flies any slower, its orbit